Hello and welcome. I am Jeti Chawam. In today's video, we are going to solve a very important structural and geology problem determining the true strike and true dip of a plane from given apparent dips using stereographic projection. This topic is important for UG examinations and it is also very useful in field geology where true dip is not always directly measurable. So let us begin and understand the concept and procedure step by steps. Here we are given two apparent dips of the same planar surface. The first apparent dip is 23 degrees towards north 284 degrees. The second apparent dip is 13 degrees towards north 176 degrees. From these two apparent dips, we need to determine the true strike, the true dip direction, and the true dip amount. Before plotting anything, let us recall one very important concept. The true dip is the maximum dip of a plane. Any dip measured in a direction other than the true dip direction is called an apparent dip. Also remember, all apparent dips of a plane lie within the same plane. So, if we plot at least two apparent dips correctly, we can reconstruct the entire plane. This is why stereographic projection is such a powerful tool in structural and geology. To begin with, place the stereo net on a flat surface. Spread a transparent overlay over the net and pin it at the center so that it can rotate freely. Using the net visible through the overlay, draw the primitive circle and mark the coordinate directions north, south, east, and west. Now, the stereo net is ready for plotting. First, let us plot the first apparent dip, which is 23 degrees towards north 284 degrees. First, locate the direction north 284 degrees on the primitive circle by counting clockwise from the true north. This direction lies in the northwest quadrant. Next, rotate the overlay until this marked trend lies along the east-west line. From this position, measure 23 degrees inward from the primitive circle along the east-west line. Mark this point and label it AD1, representing the first apparent dip. Bring back the overlay in the original north-south position. Now, we plot the second apparent dip, which is 13 degrees towards north 176 degree. Locate the location north 176 degrees on a primitive circle. Again, rotate the overlay until this marked trend lies along the east-west line. From this position, move inward by 13 degrees and mark the point as AD2. Now, both apparent dips have been plotted. Next step is to draw the plane. This is a very important step since both apparent dips belong to the same plane. We draw a great circle passing through AD1 and AD2. For this task, rotate the overlay until the points 81 and 82, representing apparent dip 1 and apparent dip 2 respectively, lie on a single great circle. Once this position is achieved, trace that great circle. This great circle represents the true orientation of the geological plane. Next, let us determine the true strike. Keep the great circle vertical and join the endpoints along the north-south line. This line represents strike of the geological plane. Bring the overlay in the original north-south position and measure the strike trend starting from north. The value is 150 degrees. Therefore, strike of the plane is not 150 degrees. Again, rotate the overlay so that strike of the plane coincides with the north-south line. At this position, mark the point of intersection of the plane with its west line because true dip direction is always perpendicular to the strike. This marked point is the true dip point of the plane and labeled as TD. Measure this angle inward along its west line from the west cardinal point. The value is 30 degrees. So, the true dip is 30 degrees. Next, determine the true dip direction. The direction corresponding to the true dip point gives the true dip direction and mark it as TDD. Now, bring the overlay to the original north-south position and measure the trend of point TDD. The measured value is 240 degrees. So, the final solution is the plane strikes north 150 degrees, dips at an angle of 30 degrees in the direction north 240 degrees. So, this brings us to the end of today's lecture. If this found useful, please like and subscribe for more lectures on structural geology. Thank you for watching.